Hi there, this is Danesh, and I'm going to walk you through an intro to terrain workflow in H16.5. So a little bit about myself. I'm the lead instructor at Side Effects, and before working at Side Effects, I was an interactive design professor with 12 years experience. So let's start talking about height fields, which is really Houdini's terrain answer. So what is a height field? A height field you can think of as a canvas which you paint your terrain on. It's a special type of Houdini volume. Remember, in Houdini, we have two types of volumes. VDBs, which are sparse volumes, and regular dense volumes, which we call the Houdini volume. So a height field is a dense volume that's only a single layer high. And it has multiple layers that can specify things like height, mass, debris, water, and so forth. It's very versatile in working with other data types. What do I mean by that? Well, you can start with your 2D images, your LiDAR data, 3D geometry that you create in Houdini or somewhere else, and you can stick it into height fields and project either the luminance of an image, the LiDAR data, the actual height of a geometry onto the height field. And you can get out of a height field 2D maps for your game engine, 3D geometry, or VDBs. So it works the way you work. It's both interactive and procedural. It has procedural erosion, masking, elevation generators, and filters. It also has paint and mask tools, so you can work interactively also. Okay, so how do you work with a height field? Well, you can either at the object level drop down the height field object, which is basically just a geometry object with a height field surface operator put inside it, or just drop down a surface operator called a height field. And the key things to know here are that when you drop it down, if you look at the information, at the very bottom here, you'll see that two volumes are created, the height volume and the mass volume. So the height is going to be basically, when you create the terrain, it's your canvas. By default, it's flat. And the mask area is going to be the entire area of that terrain. So when you're working on it, it will affect everything. The other key thing to notice here is you got to enter your size. How big do you want your terrain to be? In this case, it's 1,000 meters by 1,000 meters. And what is the density of your voxels? So as you're working on your height fields, what's really cool is there's a lot of information to extract for your game engine. Some of the more useful things are obviously the elevation. But if you're, let's say, creating mesas, it'll give you a mesa mass to say where the top flat areas are and where the cliffs of that mesa are. Flow maps, debris for erosion, your water, where it's located, and the bedrock. In addition to all that, you could also do user-defined layers to help get information for your game engine. So when you're starting to work, the first thing you're going to do is you're going to probably lay down generators, operators to block out your terrain. So again, we have lots of different generators. You could paint things, so that's pretty interactive. Noise generators, which obviously are procedural. Pattern generators, also procedural. You can project 3D objects, which are interactive. Or you can actually import stuff from other content creators like Photoshop and so forth. I should also mention that new to H16.5 is the new Manhattan and Chebyshev-Worley pattern generation. Okay, so let me show you what I'm talking about here as far as here is a blank height field canvas. And you can see that we're going to do some painting, which is interactive. We'll add some noise, and we'll then go into a CopNet, our compositing operators, and bring in the luminance of a picture and add it to it also. So here's painting, adding noise to that paint. Then here's a luminance of a butterfly and projecting that also onto the height field. Okay, again here Another blank canvas. This time I'm going to show you patterns and projection. So here is patterns, and it's really useful. You might not notice why to use patterns, but when we apply a distortion also to it, you quickly can create very unique terrains. And here I'm showing a 3D projection of a sphere in a torus. And as you can see, we just drop it down into a height field and it projects perfectly. So for the game Brimstone, what we did was we dropped down a height field, and then we added some height field noise to it to get us this kind of ground texture. Then we imported a 2D map of Mount Shasta and projected that onto it. And you can see there's kind of these discontinuities that don't look so good yet. And then we added a 2D map of the Rockies. And again, you can see these little discontinuities, which we could either fix by a little blur, or we're going to do some erosion, which will be our next step. So once you've added your generators, the next step is to do the filters. Filters take the crude layout that we just saw and really make it into something that looks like a realistic terrain. So we have, in the filters, we have things like blurs, clips, masks. We can remap the high and low points, and we have ramps on that high and low points to custom adjust it. We could resample it to a higher fidelity or lower fidelity. We could do a slump on it, erosion, distortion, terracing, lots of different filters. So when it comes to the masks, then what we could do is we could actually draw them interactively, we could blur them, we could do it procedurally by feature. For instance, we could say that we want a mask that is from 30 meters high to 100 meters high, that is only in the directions of 30 to 70 degrees with a slope of 20 to 42 degrees and a curvature of this range to this range. So we can be really precise in what areas we're masking. We have noise masks, we have paint masks to do it procedurally, interactively, I apologize. Lots of things that we could do. So here's a filter and mask example. Here's our torus, here's our noise, and you can see that it's being applied uniformly. But what I could do is I could remap that torus and the sphere to just a certain area. So I'm remapping it to 0 to 1 to make it a good mask. And now you can see as I adjust my noises, it's only affecting the area with the torus, and then I added a little blur to it. So there's a nice little bleed right here, so it doesn't look too computer generated. And here's an example of painting in a terrace. So in this case, I'm using my terrace filter with an interactive paint. So you can see right now it's just painting based on the mask that we created before. But now I'm going to put in a paint mask, and now I can just paint in where I want that terrace. Okay, and now I'm going to show you that you can actually use 3D geometry as a mask object. So you could just like drop down a box and resize it and say that's the area that I want the mask to be. So here I have a distort that I'm putting, and now I'll drop down a box. And you can see wherever that box is, I now have the distortion going on. And I can interactively resize the box to get the area that I want it to be. And obviously, it doesn't have to be just a box. It could be any shape I want. And I think finally for filters, showing you a little erosion example. Here, we're doing a resample to get a little higher fidelity. I'm putting down a road, setting up the visualization for elevation here, and then letting it erode, and you can see where it's blue, water's building, where it's brown, the debris is building up, and you get a nice erosion effect. So in the Brimstone game, To get the lava flow, we just did a localized mask for precipitation here. And then we made it a really high water flow with a low evaporation. So we got these nice rivers coming down the mountain. Then we renamed that layer instead of water into lava. And this is the final result of it. So the next thing you might want to be able to do is layer separate height fields that you've been working on. Just like a good compositor, you might want to be able to add, subtract, overlay, multiply your different layers. So in height fields, we have different layer operations. Isolate a specific layer. So remember, especially after erosion, you have things like, besides the height, you have your water layer, your debris layer. You might want to be able to just pull out one of those layers, like the flow layer. So isolate is a way to do that. We could clear our masks and clear layers. So if I don't need to know about the debris anymore, I could just wipe that layer away. I can do a layer operation, which is our compositing operator. So that's where we could add two separate layers, subtract two separate layers, and so forth. And then we can get property information, which is how are we going to kind of blend things together. So here is an example of a layer and mask. So I'm creating a separate height field. This is really exaggerated. But you can see that I could add the two height fields together, subtract, pretty much whatever I need to do. So in the race game, Brimstone, here is just a few examples of different masks that were brought into the game to figure out, where the elevation is, where the racetracks have to be tunneled down into, where there has to be berms put up for the racetrack that's above the high fields, where lava is going to flow, all sorts of different things. And you can see here's in the in-game exactly where those locations are for the roads and so forth. So you might need to visualize your height fields, and we have a bunch of different tools for that. I'm just going to show one. So here is our height field visualization, and I could actually specify, show me where the water is, show me where the debris is, the bedrock, all by properties over here. And here is a visualization from the race game showing the flow maps so we know the direction of the lava flow. So the next thing we want to talk about is round tripping 3D to 2D and back. So one of the concepts with height fields was if you're a 2D artist or a 3D artist, it really didn't matter. You should feel comfortable within this environment creating terrains. So as we discussed before, you could take either 3D geometry, 2D images, something generated in our compositing operators, COPs, and bring them into height fields and create a terrain. What's really nice is at any point, you can also take that height field and bring it back into compositing operators, COPs, for post-processing, for layer colorizing, for map generation, whatever you need to do. And if it's like, this kind of post-processing, enhancing, maybe there's a filter in COPs that you don't have in height fields, for instance, like a velocity blur. You could do that in COPs, and then it's brought in with a SOP import. And the key things here to know is there's two buttons in the SOP import. One to suck in all the layers that the height field has, so it's not just RGB. And the other one is to calculate the size of the height field, so it is proportional in size in COPs. When you do all your processing, if you want to continue it working in 3D in the height fields, no problem. You just go back into SOPs and do a height field file and bring in your COP and continue processing. So again, as an example, let's say I want to do some type of sand dune effect. Well, I can use a bunch of different blurs and compositing operators, get my sand dune effect, bring it back into SOPs, and I'll immediately see the sand dune effect, and I can continue processing or do erosions or whatever I need to do. So here's an example in the brimstone game of us bringing in the height field into compositing operators and isolating one little area of it and enhancing it through filters. So let's say your height field is now completed and you want to get into your game engine. Well, there's a lot of different ways to export it or convert it into different types of geometry. So we have this operator called the height field convert. And what it'll allow you to do is to convert it either to polygons, polygon soup, VDBs, volumes. And so here's just a little example. I'm putting the convert height field down. And you can see it's going to make it into a polygon, and it's then going to extrude a base for me. And this is really especially important if I'm working with VDBs, so I'm going to need a volume. And let's say I want to add tunnels, caves, or arches to this. That will be the next step in the process. Currently, height fields is only about height, so there can't be any overhangs. So it's impossible to do a tunnel or an arch in a height field, so you're going to need to convert it to a VDB to be able to do those functions. So again, VDBs are to add overhangs, tunnels, and arches. And here's an example from Brimstone going through the underground cavern of the volcano. So here's an example of doing both an arch and a VDB. So here you can see here I'm converting the height field to a VDB. I'm going to drop down a torus, put it in place, and then do a VDB from polygons to convert to a polygon. Then use a VDB combine to combine the two, so it's like a compositing operator, and then smooth it out. And then you'll see also that I'll do an add and subtract, so I'll get an arch and a tunnel. I should also mention that once you have your VDBs or height fields, you can convert them out, in the case of height fields, to polygons for your game engine, to maps for your game engine in 2D, or if you can handle volumes. When you convert to a VDB for overhangs, then you're much more limited. You can only convert to geometry because the maps don't make sense here. New to 16.5 also is the gamepad camera. This is really important. When I was testing out height fields, for instance, I was always messing up on my mesas and my terracing because I would look at it from afar and I said, that looks really good. But if I was able to have a little human character walking around, I would realize that the steps that I thought were kind of like this little amphitheater were, 20 meters high and impossible to climb. With the gamepad camera now, it's really easy to go in there, walk or fly through there basically, and determine the spatial relationships. So to recap this talk, really what I want to stress is how flexible our workflows are, 2D, 3D, mixing into height fields, going back into compositing operators, doing overhangs and VDBs. Knowing everything you know about creating geometry in Houdini already applies to height fields. It's super fast. You just draw, you do your filters, and you're really pretty much seeing it in real time. The only thing that you'll see a little slow down is in erosion depending on the fidelity of your map at that point. It's very art directable, right? I could use procedural stuff, I could use interactive stuff, so I could really hone on to the concept art very quickly. And again, all the power of Houdini at your disposal when you're doing this. And I didn't put it here, but I should also mention that it's also Great for dynamics. So if you're doing collision detection, particle effects, RBDs, it actually, high fields will work in our dynamics engine. Oh, one more thing. Look at the Game Shelf tool for many more tools that aid in game developers. We have stuff specifically for terrain, but we also have lots of other things to help export it to your game engines and make life easier for you. So I just want to thank you on behalf of Side Effects. I hope you go and play with height fields and really enjoy it.